For this video, let's try to evaluate the limit of this given rational function using the L'Hopital's rule. Of course, probably some of us are thinking, there is also another way for us to show the limit of this without even using the L'Hopital's rule. But since this video is connected to the concept of L'Hopital's rule, let's use it and use the other method as a verification on our answer. Okay, so let us have here the limit of your given function z squared minus z minus 12 all over z squared minus 3z minus 4 as z approaches to 4. Okay, the first thing here we need to do is, of course, verify if the L'Hopital's rule is applicable or not. The L'Hopital's rule would only be used if we could come up with an indeterminate form, either 0 over 0 or infinity over infinity, as we try the value of z approaches to 4. This would be equivalent to 4 squared minus 4 minus 12 over 4 squared minus 3 times 4 minus 4, which will give us 16 minus, of course, we also have negative 16 all over 16 minus 12 minus 4, and obviously we will get here 0 over 0, an indeterminate form. With this now at hand, let's use the L'Hopital's rule to determine further if the limit of this would exist using the concept of derivatives. Because the L'Hopital's rule tells us to take the numerator, let's say f of z, equivalent to z squared minus z minus 12, in your denominator being z squared minus 3z minus 4, and use the derivative of both, and use those derivatives to form another rational expression. And if the limit exists, that also is also the limit of the original function. The first derivative of this function here is 2z minus 1, of course minus 0, which will give us 2z minus 1, right? Okay, now for our g of z, its first derivative is also 2z minus 3 minus 0, or simply 2z minus 3. Okay, now this tell us that L'Hopital's rule is actually applicable because our second derivative or our denominator is not equal to 0. With that now at hand, the limit of the original function z squared minus z minus 12 over z squared minus 3z minus 4 as z approaches to 4, which was originally an indeterminate form as z approaches to 4, according to L'Hopital's rule, is just equivalent to the limit of the ratio of the corresponding derivatives. We have here 2z minus 1 for your numerator over 2z minus 3 for our denominator as z approaches to 4. Okay, so this is now the next process. We just need to finalize our answer here because we know that as we use our value of z approaches to 4, this will no longer be 0 over 0, right? So let's try here at the denominator, or at the bottom rather, the limit, or let's automatically substitute. You have here 2 times 4 minus 1 over 2 times 4 minus 3, which would give us 8 minus 1 over 8 minus 3, and this is actually equivalent to 7/5. This is actually the limit of the ratio of the derivatives, which is also the limit of the original function here. This function, which was earlier indeterminate form 0 over 0, but using the L'Hopital's rule, this is now the correct answer. Now, I told you earlier, there's also that one method that we can use that we have learned in our calculus. The method that will allow us to factor the original function. Supposedly, we have here z squared, if I'm correct, minus z minus 12 over z squared minus 3z, I believe it was minus 4, yeah, minus 4 as z approaches to 4. Again, this is indeterminate form, but if we're going to factor our numerator, that's actually z, using factoring, you will see here z minus 4 or z plus 3, because your AC way here is negative 12 and you will have negative z. So z minus 4, z plus 3. I'm gonna leave factoring to you as part of your review. Second, so AC is negative 4, so we have negative 3, so z minus 4 times z minus 1, or sorry, z plus 1 rather, as z approaches to 4. At this time, we can cancel this one here, leaving the value of, or the function, the limit of z plus 3 over z plus 1 as z approaches to 4. And obviously, that's just equivalent to 4 plus 3 over 4 plus 1. We will have here 7 over 5. The same value as this. So if you would like to use this, of course, you may. But since our video is strictly telling us to use the L'Hopital's rule, let's have this as part of our answer. Again, the L'Hopital's rule is applicable only if we will have here indeterminate form, either 0 over 0 or infinity over infinity, as we try the value of our c. And then if that is true, get the first derivatives of both as long as the denominator or the derivative of the denominator will no longer be 0. And then the derivative or the limit of the derivatives is just equivalent to the limit of the original function. Okay? That is for this illustration. Thank you very much for watching.